So the expansion of our species are ultimately going to lay in the hands of new technologies that allow us to travel the vast distances of space and colonize new planets. Here's a list of 10 technologies that will help us conquer the galaxy and help Elon Musk make space great again. Any long term space flight is going to leave astronauts to their own will for long periods of time. They must be able to manufacture and create new items in space as their journey goes along. Structural supports or space station critical components will deteriorate over time. The survival of each astronaut being able to manufacture these new components in space. Airbus has developed a new 3D metal printer for use on the International Space Station. The aim of this technology is to produce load-bearing structure parts that are stronger than those made of plastic. With this printer, wrenches and other tools can be constructed in space. The device is approximately the size of a washing machine. The process for creating these items is nearly identical to that of ABS machines, with the sole exception being that the wire filament must be heated to above 1200 degrees Celsius. The most crucial point in any space mission is its takeoff. During the takeoff, it has various boosters, rockets that need to be held together in order to successfully leave the atmosphere. These devices also have to deactivate and detach from the main rocket at the appropriate time. If any of these components fail, it could mean immediate death for any astronaut that is on the rocket. So NASA requires their spacecraft to maintain stability during launch and to safely eject solid rocket boosters once the fuel was depleted. Engineers determined that the optimal mechanism for this was to use an exploding bolt, or NSD. The primary component includes the initiator, which serves as the main ignition device, the sleeving, and RDX, an odorless, tasteless explosive. The system is activated at the precise moment with a voltage to ensure proper liftoff and the detachment of boosters. 8 bolts were capable of securing the rocket during launch, and 3 held each booster. The destructive force of space can deteriorate any metal to its bones. Re-entry and exiting of the Earth's atmosphere adds additional stress onto any metal and can damage it permanently, making it unusable for flight and space. So anti-corrosion needs to be applied to these rockets to prevent corrosion and keeping these metals sound and intact. So protective coatings are integral in our daily lives, safeguarding our widgets to ensure their longevity. In 1970, NASA introduced a zinc silicate coating, easily applicable to rockets. This protective layer, a blend of zinc powder and potassium silicate, shields metal surfaces from corrosion in the severe radiation-rich environment of space. Its efficacy is such that a single application suffices. Distinct from other coating, this compound amalgamates with the metal surface, forming a unified solid entity. This zinc silicate is now commonly used on ships, trains, oil rigs, hydroelectric plants, and DoD transportation. The struggle of space on the human body is immense. Death is at its doorstep at every single turn, so keeping people healthy while they're out there exploring space is essential for long-term space travel. We have to protect astronauts from the vacuum of space, heat, cold, and the void of energy throughout. Radiation is also something we got to worry about. Too much radiation can lead to sickness and death. The Timex 3 is a USB-sized device designed to detect radiation in the vicinity. Developed at CERN, contains a 256 by 256 matrix. Each of the 65,000 squares is capable of detecting radiation from space. The device converts X-rays from photons into an electric signal, enabling a computer program to digitally map the radiation exposed of an astronaut. NASA does not take astronaut safety lightly. They often implement multiple methods to complete the same or similar task. These dual redundancy systems bring the failure rate of systems to almost zero as long as the instructions are followed and verification activities catch any potential failures. Here's our first redundant system on the list. It serves as a purpose similar to the Timex radiation detection system. This time it's an advanced active tissue equivalent dosimeter. This device records the radiation absorbed by the astronaut and calculates the equivalent dose of radiation they receive. This device requires an external power supply and can differentiate between photons, alpha particles, and heavy ions. Such devices are used in hospitals with equipment that emit radiation like X-rays to monitor staff who regularly encounter radiation. So when we talk about long-term space flight and space travel, our ability to turn molecules from one form to another is essential for Earth survival. When we take a look at an example of Mars' atmosphere, 95% of that is carbon dioxide with very little oxygen left for us to breathe. In comparison, Earth has 21% oxygen and 78% nitrogen. So how this atmosphere is over there is not currently suited for us to be able to breathe, but we can change that. MOXIE, or the Mars Oxygen ISRU experiment, is a compact device that has been operational on Mars since February 2021 aboard the rover Perseverance. It has successfully demonstrated the conversion of carbon dioxide into carbon monoxide and oxygen. This chemical reaction is achieved by heating the air up to 800 degrees Celsius, followed by processing it through a solid oxide electrolysis. As one might expect, this process requires a significant amount of energy. Space is a vast wasteland with very little resources between your destination and your liftoff point. Recycling and using all the materials you have are crucial. When we go to space, we want to limit our black water and our gray water. So any long-term space flight will require a filtration of water. Unlike Earth, there's no natural filtration system built into any spacecraft. In 1960, NASA required a compact and lightweight water purification system for the Apollo spacecraft. A crucial criteria of this device was low power consumption and minimal weight. Consequently, the space agency developed the electrolytic silver iodizer. Applying a small voltage to a silver anode released ions into the water. These positively charged atoms bond to viruses and bacteria, neutralizing them instantly. The remnants are then filtered out, rendered the water free of pathogens. This technology is currently being used on the spacecraft today, adapted by multiple manufacturers to provide a chlorine-free system for filtration of your water. Sailing is an ancient technology that's over 1,000 years old. It brought us smooth sailing across the oceans and all the way to America. So how does this bridge into our space travel discussion? We have a vast distance of space that we need to overcome. Problems and challenges is we have a limited amount of fuel we can take with us. NASA has devised and built the Advance Composite Solar Sail. That is a concept that could help bridge the gap in space travel. The prototype device extends to 33 by 33 feet. The microwave-sized satellite would deploy its wings and reflect photons for the sun, propelling the craft forward. NASA plans on launching this sail on April 24th, 2024. Set your watches, people. It's coming up real quick now. With the goal of testing the boom deployment as well as demonstrating its maneuverability. Whenever you leave outer space, you leave certain luxuries back home, like wind, the sun, and the moonlight, and the water and the oceans, and your loved ones, and everything else. You also get to leave those pesky allergies as well as gravity behind you. Your life completely changes once you enter space. Keeping some of those luxuries can help astronauts and explorers on their long journey across space. So the standard convection ovens do not work properly because of the lack of gravity pull preventing airflow correctly. Instead, zero-G kitchens invented the space oven. This device functions similar to a toaster when an electric current heats wires coils to the appropriate temperature for cooking food. The food is placed inside a special design bag. This oven enables the baking of the first cookies in space. Fast travel has allowed us to conquer the globe and travel vast distances in a short amount of time. You can fly from one point of the globe to the other in less than 24 hours. Ultimately, planes fly fast, but we want to fly them faster. And there are significant challenges we must overtake in order to do this. X-59 Quiet Supersonic Jet from NASA is a plane specifically designed to fly at 925 miles per hour, which is about 150 miles per hour faster than the speed of sound. In comparison, the commercial jets reach speed of about 600. Unique feature of this plane is its ability to reduce the sonic boom noise typically produced when the object exceeds the speed of sound. This plane is currently in test flight as we speak.